In this video, we'll be going over solubility rules and KSP, which is the solubility product. So as we went over in the solubility rules, actually, the first thing we're going to do is before we go into that towards the end, we're just going to be writing KSP expressions. But before we start going into that too much detail, this is kind of like our introductory video, and we're going to be going over some basics about solubility. So, if you remember a while ago, at the beginning of the year when we were going over precipitation reactions, we remember that these things that followed this mnemonic were soluble, and some things were not soluble. For example, carbonates are not soluble. Okay, so like an example of which we did a lab on was calcium carbonate. Okay, and then this is we say it does not dissolve. Okay, so it does not make ions. Okay, this is actually partially untrue. It does make ions, and it's reversible. The process is reversible. It does equilibrium. So this actually does make a certain amount, and the amount is actually measurable. The measured amount is given by its KSP, its equilibrium constant for this process. So as a introduction, we're going to go back over a few of these old ideas about solubility. So here's Cash and Gia, the C, and then we have A, S, H, N. It's pronounced Gia, but this is actually a 1, so it's group 1A is what that means. Actually, even more than that, it's a group 1, and then the A stands for something else. Okay, so if you remember, the C stands for chlorates. Okay, so chlorates are ClO3 minus and ClO4 minus. Okay, so salts with chlorates in them, and salt meaning metal to non-metal. So metals meaning like Fe2 plus and ClO4 minus. Okay, this would be soluble, this compound, if you had FeClO4. Many iron compounds are not, but that one is. Okay, acetates is what the A stands for. Okay, and the acetates had a couple of exceptions. Sulfates, some key exceptions for the sulfates were, put a star here, the heavy metals like Pb2 plus, He2 2 plus, and Ag plus. Okay, the H stands for halides. An exception is fluorine. So except fluorine. N stands for nitrates. I believe one of the exceptions was AgCH3. I think this one is actually it's kind of like in a gray area. Okay, but I'm gonna have to look back at that one. G1 stands for group 1 is what that stands for. So group 1 in the periodic table. So that means like sodium, lithium, potassium, cesium. Cesium's a 1 plus. Rubidium. Okay, and the A stands for ammonium. So salts with the ammonium ion, which is NH4 plus. Okay, so things that do not fall in Cash and Gia are insoluble, are considered insoluble. Things such as like OH minus, or carbonate CO3 2 minus, or phosphate PO4 3 minus. Chromates are popular ones. Okay, and dichromates. So Cr2O7 2 minus. Okay, so metal salts of these ions are, and those are just some of the popular ones, are insoluble, except for group 1. So if you have like group 1 hydroxide, so that would be soluble. Okay, if you had a group 1 carbonate, that would be soluble. So that was this one and this one. So these are these two right here are the cation. Okay, and then the cation part are the anions. All right, so let's try to apply that to this. It says if the following solutions make a reaction, write the balanced net ionic equation. If there is no reaction, write no reaction. So special note that the AP exam requires you to show net ionic equations. You'll see that sometimes when you do stoichiometry, sometimes it's more useful to actually write the full compound. There's a time and place for that. But for the most part, in this unit, in our solubility and KSP unit, we'll be working with net ionic. It's much easier when you're working with net ionic and precipitation reactions. So here we're given the full compound, okay, and we want to figure out or look at our possibilities. So we want to look and see the two. We want to basically swap cation and anion. So we're going to swap those two, and we're going to ask the question, would that make a precipitate? And we're going to have to apply the solubility rules for that. So we're going to swap those two. So NaCl, okay, if that came together, that would be soluble. Okay, whereas the other possibility is considered insoluble, so we'll write that reaction. This is one of the exceptions. So it's BaSO4. Okay. There's actually, if we go back to our solubility rules, sulfates actually had quite a few exceptions. So there was another one I'm thinking of now. It's group 2 below Mg are also insoluble. So Ba and calcium and strontium sulfates are insoluble. Okay, so that one was insoluble. Okay, again, swap our ions. So K and NO3 are gonna be, that's gonna be like potassium nitrate. So that should be soluble. PB and Cl is an exception. So that one should be our reaction, PB plus Cl minus, and that makes PbCl2, so 2 chlorides. So let's again switch them again. So calcium sulfate and sodium. So this is going to be Ca2 plus and SO4 2 minus. So that will make calcium sulfate, which is a solid. And on the last one, we have these two possibilities. So we have, so on this one, we have potassium nitrate, which is going to be soluble. And we have nickel sulfide. Okay, so that would be Ni2. We know it's a 2 because of that, plus the sulfide, so S2 minus. So that's going to be NiS, okay, which is insoluble. Okay, so this is all refresher stuff from beginning of the year kind of thing. All right, so what is solubility? What does that mean? So sometimes students will get KSP, the solubility constant, and the idea of solubility. Sometimes they get those two mixed up. So KSP is for a specific substance. So this is a constant for a specific substance. So think of all the other equilibrium constants we've covered. This is actually our last one. So we went over Kp. This is for gas phase equilibrium. Okay, and working with pressures. So you have pressures in your ice table. Kc is you have concentrations in your ice table. So you could also be working with gases and call it Kc. Ka, of course, is used when we're talking about weak acids and their ability to ionize. And then Kb is, of course, for weak bases and the ability of those to ionize. Okay, so there's only one way to change K, and that's with temperature. There's lots of ways to change solubility, the amount of stuff that dissolves, the amount of ions that you could get that dissolves. There's lots of ways that you could do that. But for K, it's just like all the other equilibrium constants. The only way to change it is with temperature. And for problem solving, it's often given in some tables, so it's a constant. That's what this means. It's a constant. Okay, and just like KAs and KBs, I printed the appendix. I think it was Appendix D. There's also an appendix for KSPs. Okay, and I believe it's also Appendix D. That's all the equilibrium constants, and KSP is included with that. Okay, so what then is solubility? Solubility is the amount of solid that goes to the right. So if we have like calcium carbonate, our earlier example, so if we have calcium carbonate, okay, and it goes Ca2 plus CO3 2 minus, okay, it's the amount of ions that it makes that goes to the right is what that says. So it's the amount of this solid that makes ions, okay, and this can be it's the X in an ice table. So if you started off with, so if this were turning into some type of ice table problem, this would be dashed out because it's a solid. So this is not included in the expression. Okay, and this would be initially with 0, and this would be 0. This would be plus X, and this would be plus X. Okay, so the solubility is X. It's the amount that went over there to the right, the amount of ions. Okay, so this number can be increased in most cases, not in all cases, but in most cases by increasing the temperature, increasing the surface area, raising the external pressure. If the solute is a gas, we won't be seeing that in this unit because these are all solid ionic compounds. If you stir it, you can increase the amount that's solubilized. And we'll be working with this one the most in this unit. We'll be taking a look at this the most. And that is changing the pH if the salt is acidic or basic. So as we know, this is actually a weak base. It's the conjugate of carbonic acid. So this is the conjugate base of a weak acid, the carbonate ion. So if you adjust the pH of this solution, you could actually get more of it to dissolve. It's like if you have an egg and then you add acid onto the egg, you're going to dissolve it more because the egg shell is calcium carbonate, and what you're doing is you're adding H plus ions, and the H plus ions are going to be eating up the carbonate ions. Okay, and when that reaction happens, this number actually goes down, the number of carbonate ions. So according to Le Chatelier's principle, it's going to cause this equilibrium to shift to the right to try and make more ions. Okay, therefore causing it to be more soluble. This is a key AP chemistry topic, is when you adjust the pH. So again, this all goes back to being able to identify these very readily and fast. Okay, the ions. So like you got to know which ones are going to be basic. Okay, all right. So on to writing equilibrium expressions. So it says write the equilibrium reaction and solubility product expressions for the following. Okay, for these. So we're going to show this dissolving NiOH2. Okay, plus 2 OHs. Okay, there's a lot of stuff that's the same actually with buffers. Many concepts are the same. So this is not a very long unit because I'm not going to repeat a lot of the concepts that are the same. I'm going to really focus this unit on the topics that are different. So one thing that's major different is this is a solid. Okay, so this does not show up in our equilibrium expression, the solid there. And the other thing that's different is when we worked with acids and bases, most of the time they were one-to-one relationships. You're going to see lots of crazy different numbers here because of the charges on all these metals and all the polyatomic ions. So when we write the KSP, the equilibrium expression, it's products over reactants. So it's going to be the concentration of Ni2 plus times the concentration of OH squared, okay, because of that 2. So that's why we square it over 1, because this is a solid and it's not included. Okay, so I'm not gonna continue to write that. I just wanted to show it for this one. Okay, so now let's try this one. Okay, so this is going to dissolve and make some ions. So I'm going to first split it up. So I'm going to write Ca2 plus and PO4 3 minus. I usually omit the AQ term, the aqueous term. I'll show it here on this example, and I probably won't be showing it the rest of the unit, actually. So now we balance. So I have 3 calciums in the reactant, and I have 2 phosphate ions here. So KSP is going to be the concentration of calcium cubed times the concentration of phosphate ions squared. Okay, so now for you guys to practice on this. So here's the first year turn. Okay, and this is go over your solubility rules and see if you could do this without your notes. See if you could do it just off memory, your solubility rules in Cash and Gia. So you might want to go over the exceptions. I think we know the Cash and Gia mnemonic, and it works really, really well. So just kind of look at your exceptions too. So I'm going to move on to the next year turn. The next year turn is writing solubility expressions like what I just did. Okay, that's the end of our video, and I'll see what you guys come up with.